This lecture is going to be about limiting reactants. And limiting reactants is more or less talking about when you're given a recipe, what will run out first? And based on what will run out first, how much can you make of something? So for example, one of the things we've been using in class is the example of making a sandwich. So we have 2 crackers plus 1 scoop of peanut butter makes 1 sandwich. So a limiting reactant question would be something like this. Assume you have 6 crackers and you have 2 scoops of peanut butter. How many sandwiches can you make? And for most of us, we'd be able to do this in our head. If we take a look at our 6 crackers here, you're like, well, 6 crackers means that I need 2 for every 1 sandwich, which means that if I have 6 of them, I could probably make 3 sandwiches. With the 2 scoops of peanut butter, though, I look at this and I say, I need 1 scoop of peanut butter for each sandwich. I have 2 of them, so that means I can only make 2 sandwiches. So in this sort of problem, we recognize that it's our peanut butter that's going to be the one that's going to tell us how many sandwiches we're going to be able to make, because it'll run out first, okay? And that's going to be more or less called your limiting reactant. So a limiting reactant determines how much of something you are going to make because it will run out first. And in this case, I'll just write runs out first. It's going to be our peanut butter. Okay, so that means because of our peanut butter, we can only make 2 sandwiches. Even though we have more than enough crackers, and the number of crackers tells us we can make 3 sandwiches, but it's the peanut butter that's going to run out first, and so for that reason, we need to base our calculations on the peanut butter. So the same premise is when we have chemical reactions. So let's say, for example, I have this chemical reaction happening. I have nitrogen and hydrogen reacting together to produce ammonia. And the problem is just as I had before. You have 2.5 times 10 to the 4th grams of nitrogen, and you have 5.10 to the 3rd grams of hydrogen. So just like in the peanut butter and cracker question, we need to figure out which one is going to run out first. And based on that, that's what we're going to base our calculation on. So as always, the first thing we need to do is change grams into moles, so we can get a sense of what our ratio is. So if I do my calculation over here, I have 2.5 times 10 to the 4th grams of nitrogen, and I'm going to change that into moles by putting 28.02 grams of N2 over 1 mole of N2. Now, why is it that I'm not choosing 14.02? Because keep in mind I'm talking about N2, not just N. So that's why I'm doubling the molar mass. So on the periodic table you have 14.01. Because I have 2 nitrogens, it makes it 28.02. And that works out to be that I have 8.92 times 10 to the 2 moles of nitrogen. All right, so we need to do the same thing for hydrogen. I have 5.00 times 10 to the 3rd grams of hydrogen. Same story, I have 2 hydrogens. For that reason, when I look at my periodic table, I need to double the molar mass. So we have H2 being 1 mole of H2, and if I solve that, it works out to be 2.48 times 10 to the 3rd moles of hydrogen. Okay, so now I need to figure out which one of these is going to run out first. How do I do that? Well, I know that for every 1 mole of nitrogen, I need 3 moles of hydrogen to produce 2 moles of ammonium. In other words, I need to have 3 times the number of moles of hydrogen. So looking at this here, do I have 3 times the amount of hydrogen than I do nitrogen? Well, we can figure that out pretty easily by just choosing randomly one of these and seeing how many moles I need of the other. So let's assume that I am going to choose nitrogen. It's the first one. I can choose hydrogen, but in this case I'm going to choose nitrogen. Makes no difference. And I'm going to see, well, if I have this many moles of nitrogen, how many moles of hydrogen do I need to have? And so I simply create my ratio tile, which we've been using before. I know that for every 1 mole of nitrogen, and I know that from here, I need to have 3 moles of hydrogen. And if I work out that calculation, it works out that I should have 2.68 times 10 to the third moles of hydrogen. So let me take a look. Do I have this much hydrogen? And I look up here and I go, no, I do not. I have too little hydrogen. For that reason, I'm going to have hydrogen is going to be my limiting reactant. This is going to run out first because I do not have enough of it. So just as the peanut butter was a limiting reactant that we needed to use the peanut butter's quantity to determine how much sandwiches I can make, I need to use the hydrogen quantity to figure out how much ammonium I'm going to make. So I now need to actually just work with the hydrogen. So what I am going to do is I am going to take my quantity of hydrogen that I was given, and I'm going to figure out how much ammonium that's going to make. So if I have this much hydrogen, just going back, remember for every 3 moles of hydrogen, 2 moles of of ammonia are produced. So for that reason, I need to create that tile to figure that out. So that means for every 3 moles of hydrogen, I have 2 moles of ammonia being produced. I found that in the periodic table. So let's see how many moles that works out to be. And it works out to be 1.65 times 10 to the third moles NH3. All right. Now, based on that, I can figure out how many grams of nitrogen that is, and that's simply converting my moles into mass. So I take my moles of nitrogen and I multiply it by my molar mass. And the molar mass of nitrogen is 17.03 grams. And that works out to be 2.81 times 10 to the fourth grams of nitrogen, of ammonium that are produced. Okay? And let's just go back to the question. The question is how much, if you have 2.504 grams of nitrogen and 5 times 10 to the third grams of hydrogen, how much ammonium can be produced? I first needed to find my limiting reactant to see which one of these, is it the nitrogen or the hydrogen that I need to base my calculation on. I discovered it was hydrogen, and now using that quantity I have of hydrogen, I figure out how many moles of nitrogen that makes thanks to the equation, and based on that I can then figure out how many grams that is.